So 5.3 sinusoidal of the function of this form, a sine kx minus d plus d, f of x a cosine kx minus d plus d. You have seen this is the transformation that we have done before. A is a vertical stretch or compression. K is horizontal stretch or compression. D is a to right or left. C is up and down. Here for sine, and here is for cosine. Those are the transformation. Now here we want to see what they really mean. A is vertical stretch compression, so it will affect the amplitude, right? Stretch and compression vertically. The amplitude, which is the half a distance between the maximum and minimum, will be affected by A. K is horizontal stretch and compress, so it will affect your period. The period is the length of one full cycle. D is the phase shift, means moving to the right and left, means this starting point, where does it start? Because most of the time it starts at 0, so this phase shift tell you now where does your cycle starting. C is up and down, so it will affect the equation of the axis. So now, these are the summary. C, K affects the amplitude. So the period is the period. Period is 2 pi over K. 2 pi is 360 over K, right? If you want to find the period in radian, so you use that. In degree, you use this. Now, so let's just do a question together. Is that an amplitude of 4? When it said amplitude of 4, means A is 4, right? I'm just use another color. So A is equal to 4, right? Because we said A amplitude is A. So see, I'm gonna just make it smaller maybe for you to see it. Can we see that? See, A is equal to amplitude. So since it said amplitude of 4, A is equal to 4. How about K? Set the period of pi. I know period is equal to 2 pi over K. If I want to find K, it's going to be 2 pi over what? 2 pi over period. So K is equal to 2 pi. The period is pi. So K is equal to 2. A phase shift of pi over 6 to the left. Here is this D. This D need to be negative pi over 6, as I said, to the left. And a vertical translation of 2 units upward. So this one is up and down, C. C up means is positive 2. If that was down, it would be negative. Then I'm just putting that there, right? It's a cosine function. So y is equal to, instead of A, I put 4 cosine. Instead of K here, I put what? 2. Instead of the D, I put negative pi over 6. Negative become positive. Plus C plus 2. Did you understand that question? Yeah. Okay, I'm gonna clear that. Sometimes we need to apply transformation to to graph my function, right? Let's just do this question together. So I'm gonna put the general, then you can take a screenshot of that. Y is equal to A cosine K X minus D plus C. I want to use the mapping rule to graph this. For the mapping rule, when you have your parent function, y is equal to what? Cosine of the x. This is your parent function. You know the important point on a parent function, what is the points, right? There are key points. Let us start from 0. Cosine 0 is 1. Cosine of 90 degree is 0. Cosine of 180 degree is -1. 270. Cosine of the 270 is 0. Cosine of 360 is 1. If you want to do mapping rule, you need to transform this, like the mapping rule. This is the rule. A and C is your vertical. So it's going to be AY plus C. Whatever you see for Y transformation, you write it down. But for X transformation, you have to reverse it, right? Is K multiplied by X, you have to divide it. The reverse of multiplication is division. Minus D, you have to add D to that. So this is a transformation. Now, let's just do this example here. G of X, I'm gonna put it here. G of X or Y equal to 4 cosine of 2 x plus pi over 6 plus 2. So for this transformation, sorry, this is x divided by k here. Just this because this is for general, right? Here, okay. Okay, for the transformation, I'm having x and y transformation. Let's put it very widely. So x divided by k, what is the k here is 2, right? X divided by 2. Here is positive, so you turn to minus pi over 6. Make sure if this is negative, it turns to positive. If this is positive, it turns to negative. And for y, it's gonna be 4 multiplied by y plus 2. See, I'm gonna do that. So I put 0, so this is my original, my parent function. So you put 0 for x, 0 divided by 2 minus pi over 6. 0 minus pi over 6 is what? Pi over 6. So what I do, I'm gonna turn all of that in pi because this is pi, right? This should be in radian as well. So 90 degrees pi over 2, just convert everything. So this is pi. This is 3 pi over 2. And here is 2 pi. So I put 0 here, pi over 6. Now for y, I put 1 plus 2 is 6. Next one is pi over 2. Pi over 2 divided by 2 is pi over 4. Pi over 4 minus pi over 6 is 2 pi over 6. 2 pi over 6 is pi over 3. Now it's 0. So if you put 0 here, 0 plus 2 is 2. Now I put pi over 2 minus pi over 6 . 3 minus 2 is 2 pi over 6 is going to be, sorry. This is multiplied by 3. 2 pi over 6, 2 pi over 6, pi over 3. Maybe I just made a mistake here, guys. Maybe just put that there. 6 minus 4 is 2. Okay, so this is gonna be pi over, 2 pi over 24. It's gonna be pi over 12. I have to correct that one. This one is pi over 12. This one is pi over 3. So this is, write it down. This is pi over 12. Now for 180, that pi I put there is -1, -1. 4 multiplied by -1, -4 plus 2 is -2. Now I put 3 pi over 2. 3 pi over 2 divided by 2 is 3 pi over 4 minus pi over 6. It become 18 minus 4 divided by 24. It's gonna be 14 over 24 is 7 over 12. 7 pi over 12, right? And the last one is 2 pi. 2 pi divided by 2 is pi. So it's gonna be pi minus pi over 6. Become 5 pi over 6. Okay. See, because the denominator for all of that, okay, I didn't put the x for that. The x for that was 0, so I put 0 is gonna be 2. The x here is 1 for the last one. 1, just gonna be 6 for this. Now, since to make it easier, I would like that all of this number that I get for x have a same denominator. For example, if you multiply this one by 2 and 2, this is gonna be what? 2 pi over 12. Why I do that? You see, it's easier to graph it. See that the common denominator between 6, 12, 3, 12, 6 is 12. That's why. So it's pi over 12, the denominator is 12 is good. This one multiplied by 4. Denominator and numerator is give me the denominator of the 12. So this is good. The denominator is 12, and this one is 10 pi over 12. Now let's just quickly graph this. Maybe I just move that to the, and use the black, maybe. So what I do pi over 12, right? Each unit is pi over 12. I have to graph it 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my last number. And here from that, since this is negative, right? I have to do 2 of them at this side. So first thing you do your axis. We said that the 2 is your axis, right? Now the maximum is 6, the minimum is -2. So 1, 2, 3, 4, 5, 6. This is your maximum. Your minimum is -2. How do I know? It's just see the lowest number is -2 and the maximum number here is 6. So the axis is gonna be the midpoint between the max and minimum. What is the midpoint? You could guess is 2. See, this is 2. This would be my axis. I can put that there. Or just, you can get the equation. This C here, which is 2, will tell you the axis. Now, I'm gonna graph that. For -2 pi over 12, it is 6 at maximum. So this is, everything is pi over 12. See, this is pi over 12 is -pi over 12. So this becomes -2 pi over 12. Right? At this point, you are at maximum. Pi over 12 is here. At pi over 12, we are at 2. Then 4 pi over 12. 1, 2, 3, 4. This is 4 pi over 12. At 4 pi 12, we are at minimum -2. 7 pi over 12. And then 10 pi over 12, again, this is 10 pi over 12. Again, we get to the maximum, which is 6. Right? And I'm gonna connect it. Make sure you connected like a curved line and put this curve nicely. I try my best here. That's that. If you want to continue, so it's easy. 1, 2, 3, you go to maximum. So the 3 more, you get to the symmetric line. I don't have a space here to show you, but maybe at the other side I can continue. See here, one is from the symmetric is 1, 2, 3 to the maximum. So 1, 2, 3. You get to the symmetric line every 3. See, just want you to make sure you note that from the symmetric, this point, 1, 2, 3, you get to maximum. So 1, 2, 3, you have to get to the symmetric line. Again, 1, 2, 3, you have to get to the minimum point. So you can continue this. This is like a pattern that you can find out. So I want you to take a screenshot of that, please. So sinusoidal function transformation worksheet for 5.3. The first question, second question, third one, fourth one. Question number 5. And 5, 7, and 9. This is very important. Question number 11, 12, 13, 14, 15. So the answers are here. What I'm looking for that you understand it. I'm gonna just